Hi there, fifth graders. It is time for our next unit in math, lesson 1. We are in unit 3, and we're going to learn how to multiply and divide fractions in this unit. So we're going to spend the beginning of this time learning about multiplication. The second half of the unit we'll learn about division. And I, of course, always want you to have a visual model connected to what you do. So that's kind of how we're going to begin, and we'll come up with the standard algorithm, the set way that most people solve these problems after you see the visual model. So to start off, it says visual/area model. I'm hoping you remember, it's been a while, so if you don't remember, it's okay, I'll refresh your memory. But you learned, and again, you should write down everything I write, then I'll know that you watched this. So for the visual area model, let's think of a problem like way back when you had to do like 2 times 3, okay? So we know that 2 times 3 is 6, right? But one of the ways you learned to solve this was to use square units, okay? Like actual little squares. So for 2 times 3, you could look at this as having something that was 3 units by 2 units, right? So 3 by 2, and to figure out what it was, we filled in the rest of those squares and saw that it is 1, 2, 3, 4, 5, 6. So this is called an area model because in area you are finding the number of square units in a rectangle or a square, and all you have to do is take the length times the width. 3 times 2 means that there are 6 squares total. So we can actually apply this understanding to fractions. And seeing that visual is part of the standards that I have required to teach you. So I know some people at home probably like, why are you drawing these pictures? This is the rule, this is how you do it. When you are requiring students to have a visual model, I can't just teach the rule, so you have to understand this visual model as well. And it does make you not just memorize a rule, so it's good stuff. So bear with me, that's the moral of this story. Right now you should have this picture drawn on your paper. Okay, so we're gonna use this visual model, and I have 1/2 times 1/4. And this is kind of hard to think about, like I have 1/2, 1/4 of a time, like what does this mean? So I just said 1/2, 1/4 of a time. You can look at this little multiplication sign as the word of, and it will help tremendously, especially when we get to word problems in a couple days. So this means 1/2 of 1/4. So what we're gonna do is, just like I had 2 times 3, I have 2 by 3, and then I just count the squares, we're going to put 1/2 and 1/4 in here. So to start off, let's put 1/4. When I wanted 3, I made it 3 units wide, right? So if I want 1/4, that means that I need to cut this whole up into 4 pieces. So go ahead and do that. I'm just gonna draw our lines in, and do your best to make them the same size sections, right? See, mine's like, this one's a little bit big, but just do your best. Doesn't have to be perfect. We can still get the idea. And if I wanted to show 1/4, I would just shade one of those pieces. So you just, with your pencil, can lightly shade in 1/4. So this right here is your 1/4, just like this up here was your 3. Now I want to show the 1/2 because I want to take half of 1/4. So I'm going to flip my paper this way to show 1/2. So that means if I want to show 1/2, I need to have 2 sections. So 1, 2 sections, right? And if you have 1/2, that means that you have 1 out of those 2, right? So this shows 1 out of 2. So we're showing half this opposite way. Now when I flip it back, this right here represents 1/2, right? So if I want to do 1/2 of 1/4, do you see how this was 3 times 2 and I counted all those pieces in the middle? Now my answer is just this piece, because this is 1/4 and this is 1/2. So your answer is whatever this part is of the whole. So let's see, I can see that I have one piece that has both of them shaded, right? This one just has the purple, this one just has the green, this one has purple and green. So this one piece is my numerator, that's the part. And now the whole is how many pieces this is cut up into. And now I can see it's cut up into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So that means that half of 1/4 is 1/8. Okay, let's try another one. We've got 3 more, and then you'll see this in your bell work throughout the week as well, starting tomorrow. All right, 1/3 of 1/4. That's what this multiplication sign means, 1/3 of 1/4. So I'm gonna go ahead, I'm gonna put 1/4 on here again. 1, 2, 3, 4. And I'm gonna shade in 1/4. So right here, this is my 1/4, this little chunk. Now I wanna take 1/3 of 1/4. So I just showed 1/4 this way. I'm gonna turn my paper. Now I wanna show 1/3. That means I need this to be cut up into 3 sections. And if I have 1/3, which that's my starting number, my starting factor, that means I'm gonna shade in 1 of those 3 sections. So this little piece here shows 1/3. So just again, like I had 2 times 3 and I counted the squares there, I'm gonna do the same thing here. And 1/4 goes to here, 1/3 goes to here. So this is my answer. Okay, 1/3 by 1/4. So I can see that I have 1 piece out of the whole that is shaded out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, let's keep on going. I have 2/3 times 4/5. And I know it's tempting to want to skip this part. Don't skip this part. You have to have an understanding of the visual model. It's part of the content standards you need to know. This will be on all your standardized test stuff. All right, 2/3 times 4/5, so 2/3 of 4/5. First step, I'm gonna divide this into 4/5. I'm sorry, I'm gonna divide this into fifths and shade 4 of them because I want to show 4/5 across the top. So that means I need 5 sections here. 1, 2. Try to make them all the same size. 1, 2, 3, 4, 5. And 4/5 means I should have 4 of those shaded. 1, 2, 3, 4. And again, if this takes you longer than it's taking me, then pause it and get caught up. It's the beauty of the video. So I want to do 2/3 of this 4/5. So right here, this whole amount up here is my 4/5, right? This is not included in the 4/5. This is what I'm dealing with. For 2/3, I'm going to turn my paper, and I need to have 3 sections because it's 2/3, right? So that denominator tells me how many sections. And if I have 2/3, that means that 2 of these sections are shaded. So I would shade all of that and all of that. So this right here is my 2/3. So this is 2/3, this whole thing up here is my 4/5. So now my answer is that boxed in part that goes from 4/5 to 2/3, which would be this. It's where they're double shaded on yours, so it'll be darker shaded. Okay, so my answer would be 1, 2, 3, 4, 5, 6, 7, 8 pieces out of 9, 10, 11, 12, 13, 14, 15. So 8/15 is the result of 2/3 times 4/5. Okay, letter D, 2/3 of 3/4. So I'm gonna go ahead and I'm gonna put 3/4 on here. That means I need 4 sections with 3 of them shaded. 1, 2, 3. And okay, so right here, this is my 3/4. Okay, now I want to take 2/3 of that. So I'm going to turn my paper. I'm going to cut this up into thirds. And I'm going to shade 2 of the thirds. So 2/3. So that means that this right here is my 2/3. So the answer is where the double shading happens, okay? And the double shading happens there. And I can see that I have 1, 2, 3, 4, 5, 6 pieces out of 7, 8, 9, 10, 11, 12. 6/12 are shaded. I don't know if you're looking at this 6/12 and you're like, Mrs. Tremblay, you said that makes your eyes hurt. My eyes. Yeah. So instead of 6/12, we can say 1/2. If 6 out of the 12 pieces are shaded, then it is 1/2. So 1, 2, 3, 4, 5, 6 compared to 1, 2, 3, 4, 5, 6. Yes. Okay, now we're going to use this visual model to help us come up with how we solve this traditionally. And the traditional way to solve it is called a standard algorithm. Sometimes it's called a traditional algorithm. Either word means the same thing. And I ask the question, what patterns do you see that could help you solve these in a faster way? So I'm hoping right now that you kind of get an understanding of the area model of this, the length times the width of it. And now I want to know, instead of drawing these pictures, what could I do to quicken this up a little bit? So what can you do with 1 and 1 to get 1 and with 2 and 4 to get 8? That's the same operation. 1, 1, 1, 3, 4, 12. 2, 4, 8, 3, 5, 15. 2, 3, 6, 3, 4, 12. You can pause for a second, see if you can come up with a little rule of what it looks like we're doing with our numerators and denominators to get our product, our answer. All right, hopefully you are seeing that all we are doing is multiplying our numerators and multiplying our denominators. 1 times 1 is 1, 2 times 4 is 8. 1 times 1 is 1, 3 times 4 is 12. 2 times 4 is 8, 3 times 5 is 15. 2 times 3 is 6, and 3 times 4 is 12. So all you have to do is multiply the numerators and multiply the denominators. That's the standard algorithm. So these are the same 4 problems that you just did. That means instead of drawing that out, which you do still have to have the ability to draw it out. You will see that on a test or on a quiz from me, being able to use the area model. That is something I'm required to teach you how to do. But yes, I like this way too. 1 times 1 is 1, 2 times 4 is 8, so we do get an answer that matches our starting. 1 times 1 is 1, 3 times 4 is 12, and yes, that matches letter B. 2 times 4 is 8, and 3 times 5 is 15. That matches our C. And 2 times 3 is 6, and 3 times 4 is 12, which matches that. And of course, I would prefer you to tell me 1/2. The simplifying part, I think, is the trickiest part of the unit, but that will come with time. So let's try this. Let's find each product, and we'll make sure that we simplify our answers when we can. And when you see that you're supposed to multiply 2 fractions, this means 2/3 of 4/7. So of, that's going to be a key word for multiplying fractions. All we have to do is multiply our numerators. 2 times 4 is 8. Multiply our denominators. 3 times 7 is 21. And then ask ourselves, is there a number that will go into both 8 and 21 other than 1? The answer is no. That means it's in simplest form. So 2/3 times 4/7 is 8 over 21. For letter F, 1 times 5 is 5. 4 times 6 is 24. There's not a number other than 1 that goes into 5 and 24. That's my answer. For letter G, 1 times 3 is 3. 2 times 8 is 16. There's not a number other than 1 that goes into 3 and 16. That's our answer. 1 times 1 is 1. 6 times 3 is 18. That is already simplified. 3 times 1 is 3. 7 times 3 is 21. Is there a number that goes into both 3 and 21? Yup, 3. I need to divide those both by 3. And 3 divided by 3 is 1. 21 divided by 3 is 7. So 1/7 is what you should have. 1/7 is equivalent to 3 over 21, right? Because I can take 1 times 3 to get 3 and 7 times 3 to get 21. But I want the simplest form. I want the smallest digits possible. In letter J, 2 times 7 is 14. 10 times 7 is 70. Is there a number that goes into both 14 and 70? Yeah, well, I know that they're both multiples of 7, so let's see if 7 is the largest one. 14 divided by 7 is 7. 70 divided by 7 is 10. And there's not a number other than 1 that goes into both 7 and 10, so that one's simplified. All right, so after this, I do want you to make sure you're doing the whiteboard practice problems. Please don't skip that step. It lets you come into class really understanding what you're doing so that we can continue to move forward. So get your whiteboard materials, or if you wanted to solve these on scrap paper, that would be fine. But don't skip the practice session. That's what you should do next. Thanks for watching.